Thank you. Yes, first of all, I would like to thank the organizers of this workshop for inviting me. It's to be an honor to be here once again. Also was here in 2013 for another presentation. And I'm following TICAT with great interest. And I think it's been very interesting so far. What I want to present today is something which goes across what we already heard yesterday and also today on the environmental issues and the vulnerability issues and also the governance and the participatory things. First of all, I'm from GEUS. GEUS is the Geological Survey of Denmark and Greenland. And at GEUS we have a lot of different departments. The most important ones are on oil and gas and energy and also on geological mapping of Denmark and Greenland especially. Our department is the only one. There's nothing to do in Greenland, hydrological research. So originally we do a lot of work on groundwater mapping and modeling, but in recent years we have been doing climate change adaptation, and so that is why my interest in TICAT has been evolving during the project lifetime. And so my talk today will be on participatory early warning and real-time modeling. And it's basically about making a better use of local knowledge on hazard flooding and the risk of hazard flooding. And so you can see here on the first picture is how the flooding event unfolded in 2011 in Copenhagen. There was a major event which also happened to trigger the climate adaptation plan. So something was already going on, but it has been evolved much faster after then. Not sure, is there a pointer? Okay. Thank you. This one. Okay, I'm sorry. Yeah. Okay. So basically, I want to talk about getting information, local information from app devices and into a system to monitor what is happening in connection with floods. And after this presentation, I want to give another presentation on the urban proposal, which is also involves TICAT as a consortium. But before that, I will concentrate on the early warning system. So, sorry. Just fixing it again. Okay. Okay, so. Okay, there we go. So you can see even though the events are not as extreme in Denmark or in Europe in general as they are in Taiwan, still we have we have a lot of floodings experiencing, and you can see some examples here from Denmark. As I told you, we had these extreme rainfall events in 2011. You can see here on the radar picture that it was a very high rainfall intensity, which the sewer system could not cope with at all. And so a lot of water was flowing into the streets in Copenhagen, which is a very rare event. And so this triggered climate adaptation plans, the cloudburst plan, perhaps you have heard about it. And since this has been rapidly evolving into a lot of different climate adaptation plans all over Copenhagen city. All parts of the town needed to submit a climate adaptation plan on how to handle these type of events in the future. So what we see is in the winter we have stronger storm surges, we have increased risk of flooding, increased runoff, and in summer times we also experience longer dry periods and increased irrigation for agriculture. So this I think is calling for an improved early warning system. Early warning systems have been around for a long time, and you already have a lot of experience in early warning systems for tsunami and for coastal disaster events. But what I want to focus on in this talk is on early warning, mainly for river flooding, which I think also is important for the TICAT case, because even though you have coastal flooding, you have also a lot of water coming from the hinterlands, from the mountains in the rivers, and that is just aggravating the flooding situation in cities like Thailand and Taipei. So this is the general definition agreed on in the early warning system, and you can see the early warning in this picture of the total risk management cycle. So also early warning has been endorsed for a long time. You see there's an early warning obligation actually from 1992. And in the Riga Declaration, the Yokohama Strategy, then we had the Yogo framework, which just closed. And now we have the Sendai framework for action recently adopted, and you can see it still says substantially increased availability and access to multi-hazard early warning systems. So it still has a very high priority, and we can all understand why. You see early warning systems, it's on the local level, it can be at the national level and regional level. And what I want to focus on here is on the local level. And you can see here that in this part, you may say, well, there is this opportunity for a two-way participatory early warning system. And that is something we experiment with. And you can see, if you are interested in the new research programs from the EC, in the Societal Challenges early warning system is actually also mentioned, and also participatory early warning is endorsed. A two-way system, usually we think of early warning as a one-way system. There is information available from different sources, maybe from remote sensing, can be from different measuring stations, and the people in danger are warned by this early warning system, and they are the users. So they need to know where flooding is supposed to be happening, and they can react accordingly. So that is interesting and important for the response phase. You can see here on a few examples I found for active monitoring in early warning systems. We have some examples from Japan, and from China, India, Australia, USA, UK, on two-way systems. So in two-way early warning systems, that is where the public who is going to be warned in the end is also actively supporting and contributing to the early warning system. So and that can be like monitoring water level, can be monitoring groundwater level, but also in the social way that you can give information, provide information to a database on how the situation is and where exactly there is a need for response. So also you have early warning at the different time scales, so-called nowcasting, real time. You can see here some examples: earthquake, tornadoes, and you have short-term forecasting in minutes, hours, or hours based on medium term and long term. And for long term, we think about sea level rise, deforestation, so the type of natural hazards we heard about this morning, so-called creeping hazards. Also for those, you have early warning systems, but we are mostly concerned about the nowcasting and the short-term forecasting in this case. So, activities to consider if you have active participatory early warning system. It's also sometimes called people-centered early warning system. It is about to confirm about the hazard information monitored, whether that may be adequate or not. You may think of the people having the local knowledge in the community. They know best where you should provide information about for an early warning system, so you make use of this information. It also is an active bridge between the national and official early warning system and the community, so there's also a communication aspect in this case. So also stating here, communicate with the community what the monitoring information is used for, and also we have been mentioned it a few times yesterday and today about the uncertainty, to disclose information about the uncertainty and to make it as transparent as possible, so it prevents inaction. I think that is also something which is very important and is something we usually do in Denmark. We do not provide any information with one number underlined, and we say, well, there's a range, and the range can be large, can be small, but to give you some information about the uncertainty, and so it will not end up in inaction. And then there's the dialogue with authorities and the scientists, important as well. So the continuation will basically mostly about the Hydrologist project, where we try to apply this information. And we build on what we already have achieved in other projects where GEUS has been involved in, both the national and European projects. So the Hydrologist project is the Nordic Center of Excellence for Resilience and Social Security, and it's about a whole range of social security issues and resilience, ranging from psychological resilience to the national, to physical resilience. And so one of the work packages, one of the tasks in which we are involved is participatory early warning and monitoring system for natural hazards. So we have the problem, and this is the problem within the context of the Hydrologist project, which is a Nordic country project, and the Nordic countries like Sweden and Norway and Finland, the information may be very sparse. It's very sparsely populated, especially in the northern part of the Scandinavian countries, and so sometimes information, often I would say, sometimes information is missing in early warning systems. And the question is how you can deal with this. Is there a way of in a doable way, an economic way to enlarge your monitoring network and to make it more appropriate for the Nordic countries? And so usually there's a dense network. Everybody can be online somewhere in these areas. And what is tried here is to see whether you could submit information by mobile phones, by apps, especially dedicated to this purpose, to a central database, and the database will then update an early warning system, and can also couple it to a real-time modeling system that of course requires you have a model set up for this area, and if that's not the case, you can still use this information to give timely and appropriate warnings about imminent disasters like flooding. So, as an example, you could, for flooding hazards, you can provide improved forecast or damage on critical infrastructure. For instance, if you are in the catchment area somewhere leading to a city, to an urban area, and you have information about the river discharge, so maybe the velocity or maybe the level, the water level. You can easily, with dedicated apps, you can make a picture of it. It will be automatically processed and sent to a database, which will then update your early warning system and then feedback to the people who need it. So the problem we try to solve here is to increase the density and the resolution of observed data for the early warning system, which usually is too low. And as I mentioned before, it is not about a one-way system where people are warned, as usually is the case in the early warning system, but there's a two-way system where people also feedback, provide information to the database, to the early warning system, and in that way you may dramatically improve your early warning system and give timely and accurate information about the imminent disaster. So the network-based public participation is the main issue here. We have public observations. There may be physical information or maybe social information, and you submit that to a central system which updates the early warning system. That's basically the idea, and that will give you more timely and accurate warnings, a much more comprehensive combination of damage effects, especially regarding critical infrastructures. So those are the physical sensors I talked about, but also it can increase your public risk perception and hazard awareness, and those are the social sensors. And for this, we work together with another project funded by the EU called We Sense It. It's on citizen observatories where they have developed special apps and special dedicated software for doing this. And this sounds very advanced, and it may also be very advanced, but you must realize that most people are in the position of a mobile phone and smartphone, and so and this kind of software is freely available, and it's very easy to use. And it can really dramatically improve your early warning system and your information about imminent hazards. So, the project I was talking about was the We Sense It project, where they already have experimented with different participatory early warning systems. And for this, we need to do a complete review. What has already been done, and see whether or not it can be applied for the Nordic context. And we think it can. So we have case studies in the Nordic countries, in Sweden, Norway, Denmark, and Finland, and Iceland also. In Iceland is not only dealing with flooding, but also with earthquakes. So that may also be information which at the later stage perhaps can be used for Taiwan also in TICAT. So this could be interesting. We have also stakeholder involvement, which is very intense. Not only by having the stakeholders as participatory sensors, but also having workshops and actively debating, discussing what kind of information would be of most use, and in that way tailor the system in the most accurate way. And so what we need to do is then to, after we consult the stakeholders and use these from experts and the public, We have a plan of developing a web interface prototype, which both supports one-way system, so from the public to the early warning system, but also back again from the early warning system to the public, so they easily can find their way in the risk warnings. And so in a unique way, so there may not be any misunderstandings about where exactly the danger will be. So this is an example I want to use. This is something we will use in the Northwest project. We already have GEUS an early warning system in development, and this is still a work in progress because the early warning system is coupled to a real-time monitoring and modeling system. And we want to develop and test this further in Northwest. So we have a model for Denmark. Denmark is the German border. This is the island sea where Copenhagen is situated here. This is Sweden on the right side, and Jutland on the left side, and here the North Sea, the Atlantic Ocean. And this is the modeling system I was talking about. It's a dynamic system. There's a groundwater component, a surface water component, and it is set up for the whole of Denmark. And so we use it for, traditionally we use it for making assessments of groundwater resources and drinking water resources. But it is a physical model, and it can as such be used for developing scenarios on the climate change, and that's what we do. So climate change effects on the precipitation and the temperature can be input to the model, and it will give you some changes in water balance, groundwater level, recharge, and runoff. And runoff is the component we look at in flooding, even though groundwater, we have not mentioned this before, but groundwater also is a very important component of surface runoff. If you see an urban area as part of a catchment, and groundwater is increasing in urban areas, then this may also result in that the sewer system cannot function properly. And so in some areas, as the Copenhagen area, the groundwater modeling, the groundwater observations are also important when you look at the urban runoff. And it's also important, and that's why I made this remark about the geology below urban areas. It's also important to see where actually excess water can be infiltrated in urban areas. So we use it for a real-time warning of hydrological events, so flooding and drought. We also have drought in summertime, because in wintertime we experience flooding, but in summertime we have prolonged high temperatures, and that may result in drought. So we also look at warning for drought. And this you have seen yesterday. We also use the same kind of models, but though we do not use the Japanese in this case, but the English model or the Danish model. And so we have climate modeling here, and we have a regional climate model for Europe, and then we have several techniques that was presented yesterday on how to downscale from, and so on. We'll not go into detail about this. We use it for climate adaptation projects, like here. We have a highway system which has been lowered in order this is a highway system where we have different pumping on the left side and the right side in order to avoid flooding of the system, and this is also part of the early warning system. But what I really want to talk about is the participatory hydrological early warning. So this is the paradigm shift. I want to stress that it is a shift from one-way communication to two-way communication, and so the stakeholders will become from passive stakeholders to active stakeholders in their communication with the early warning system. This is the principle of the participatory early warning, and you can see the 4 boxes. They are all interacting, and the public knowledge for the early warning system is actually improving what is in these boxes. For instance, the risk knowledge, so the knowledge of the relevant hazards, that is best known by the local people, and so that is incorporated in this early warning system. The monitoring and warning system is the most important, you may argue, and so we have a technical capacity to monitor these hazards, and therefore with that we use the mobile phones or mobile devices. Any mobile device can be used for this. And dissemination and communication is important, and for this we also need to know the local stakeholders to disseminate and make it understandable for everybody and for the people who are at stake. And also the response to this capability is at stake here, and best known by the local people, of course. This is an example of an early warning system from the Sensit project. You can see here there's a river, there's a bridge, and you can stand along the bridge at some point and monitor the river, the water level in the river somewhere here. You can see the software app will automatically process this information, so the GPS will know where the bridge is, and will also, from the recorded water level issue, process the information, so it can be used by the early warning system, and so and this is done by the mobile device, by the app, and so it will feed back into the early warning system, and this loop is then updated all the time. So you are really doing real-time monitoring and real-time early warning. So this is the network. So these are the public sensors, you may say, which are feeding into the system, the early warning system. The early warning system is then visualized using different type of softwares. And the early warning system is then feeding back to the system, and in the end, the public is warned about imminent disasters. This is the big picture. So, for the DK model, which is the Danish model, we have this problem, this scheme with the updated DK model using the climate information from the Danish Meteorological Institute. So we can make forecasts at different temporal and spatial levels. And then we have the decision support system at the local level. And you can see here the combination of the monitoring data and the local knowledge, and the Bayesian network decision tree, which I mentioned. We use this for updating the system and feedback to the model, to the early warning system. So the local data, as I mentioned here, is updated from this part of the system. So it's much about how to optimize your network, and in this way, I think in a relatively economical way, you can make your observational network much larger and much denser than it was. So you can see here in this picture, your cost and your environmental state uncertainty will decrease. So you will know more about your information, you will know more about your system and flooding hazards, and do it in the economical way. some forecasting. We can support the different time scales. So we are mostly looking at this time scale, 10 to 50 days. But at the longer term, things more and more complicated. So that's something we do not address in the Norway's project. Here you can see another example of a river in Denmark. This is in the western part. You can see here how the water level is measured. This device is usually this is done continually, but for the purpose of the project, we installed this meter here, and the software installed on your mobile app can then automatically record this information, so the river level, and the software, the app will then automatically submit this information to your early warning system. And so that will improve your observations, and it will also improve your real-time warning system. And in the end, it will improve your early warning system. This is just some examples from this area. Also, not only in Copenhagen we have experienced serious flooding, but also elsewhere in the country. And we use the different setups of different cities, different urban areas in Denmark to test the system. We also use participatory workshops where we actively, okay. Is this also for the second presentation? Yeah, okay, I'm sorry. Okay, I'll skip the workshop. And also the results. The results were actually showing that it wasn't found important. And it was, and people had their own ideas about how to design such a participatory early warning system. And now I'll skip the results of the workshop. So this is what we do next within the Norway's project. So we developed this early warning system, and we use the case studies, and you can see here. And I hope to present some results next time. These are in short the results and the expected results. I mean. In collaboration with Icelandic Met Office and the Finnish Met Office. Okay, I'm sorry. Can I just shortly see the other? The next one I will do really fast. Sorry about that. Yeah. Yes, the next one is very fast. I hope is the Clean Urban project, the proposal, in which we have a collaboration with the TICAT. TICAT is an associated partner in this Interreg proposal, as we call it, for the Baltic Sea. And you can see the problem is the Baltic Sea here is a very polluted area, and what we look at is how we can decrease the output from cities around the Baltic Sea into the Baltic Sea. And so we think this is very important also for the TICAT case, even though the geographical settings are very different. The main issue is the same. You can also imagine that if you have urban flooding in cities in Taiwan, that may also resolve a lot of pollution on the street and on different other sources, and that may end up in the water, the coastal waters. And we already saw a few times that, for instance, in Taiwan, you have a very delicate ecosystem just outside the town, and just so this problem is also very relevant for a target setting, I think. So what we look at is the capacity of cities to decrease the discharge of hazardous substances from urban areas to the Baltic Sea. And that is the main part of the proposal. How we can do this? Different measures you can think of, and those are developed and applied and tested for different cities around the Baltic Sea, and we hope by doing knowledge sharing to share experiences from these Baltic cities to Taiwanese cities also. Because here the cities involved Copenhagen, Hamburg, Helsinki, and we have so, as mentioned before, the associated organization for Spain and Taiwan take at this part. And here again you can see the extreme rainfall events that we have experienced in Copenhagen, and that will cause both quantitative, which we usually focus on, but also qualitative problems, which has been undervalued in recent years, but which is very important. So we have a Copenhagen case where we look at different waste dumps and different and analyze the pollution that can be washed out into the Baltic Sea from the street level, from the sewers and the street level, and see what kind of measures we can think of to reduce this. I'll skip this one, and this one also is showing that this is for another town in Denmark, where we have a lot of underground and surface waste, which may be at the risk of being dissolved and it comes up. I don't know, share these ones, and just thank you for your attention.
Thank you, Peter. Is there any questions?
The participatory, the early warning system, you finished or you haven't? It's still ongoing. Is this applied in Denmark already?
This is an ongoing project. It's collaborating with other projects who already have developed or in the process of developing an early warning system. This is the very early warning system.
Yeah.
And we are halfway, say, in our attempt to combine this early warning system with a real-time modeling system in Copenhagen. And so, and this is further developed in the Netherlands case.
I have a technical question. You have a loop there. You show a bridge there.
Yes.
How you can make sure the public person would capture the whole bridge rather than just half the bridge? How you gonna?
Yes, that's the public is guided by the software. So the app, this is a dedicated app. It's not just a camera
right.
on the phone. It's an app which will in some way do some pattern recognition.
So you should help you to
help you to make the pictures.
About the early warning system, in your project, have you studied who is the proper authority to release this warning system? Because sometimes it's a local level or national level or even regional level. Who has the authority, and what is the proper way to release this kind of information? Because there sometimes it's a false alarm, and then people will complain or have something. I mean, then who is going to be able to
yes, well, the authority to provide the climate information to the system is the national level. You say it's the Meteorological Institute, but the early warning system is operated by the region, and in some cases by the community also. And so that is the authority. So it's different. It's across all levels. But for instance, for Copenhagen, the early warning system would be operated by the Copenhagen Metropolitan Area Authority.
Yeah, let citizen to help to upload the data. I think it's a very good idea. But my question is, are there many citizens help to upload the data in your experience? I mean, if you hope a citizen to upload the data, that can increase the observation.
Yes, this is a very good question. Thank you. And for this, we use the workshops to make people aware of the situation and make also clear to the people in the workshops that they are the main beneficiaries of this information. And so, yeah, so it's a win-win situation. And you're right. It is volunteering. Those are not paid officers or paid people. It's people living in the community which are using this type of apps for in case of emergency. And so for them, for everybody in the community, it will be a win-win situation because they will provide the information, but they will also benefit from it.
Small question: can we download the app? The iStore or something?
Yes, the app, well, the Northwest app is not available yet, but there are other apps, and I can give you a link to some of the apps which can be downloaded already. Yes.
That would be great.
Yeah, it's actually we also work with a private company in the Netherlands called Hydrologist.com or .nl, and they also developed apps for doing this, and we try to build on their experience, so not to have to start from scratch, but to build on their, or to collaborate with them to build the app which would suit our curves. So, but that one can be downloaded already. Yes. Give you a link.
Yeah, I appreciate it. Thank you. So, this is also very brief. After the releasing of the flooding events, once that's being publicly announced, what's the next? Do you have an evacuation map, for instance? And then what?
Yes, there are all the communities in Denmark are obliged to develop emergency plans, climate adaptation plans. So they need to account for climate change effects, and those plans are in the process of being finished now. I think that the last one was submitted about the beginning of this year, and so they need to indicate how they will deal with flooding under the current situation, but also under future climate change, and that will include both spatial planning aspects, but also if spatial planning is not appropriate anymore, how they will respond to emergency situations. So evacuation plans has also need to be developed. Are part of this plan. It's more or less the same process as they use in the Netherlands. That is a 3-layer safety system. The protection, the dikes is the first system, and the spatial planning, the room for the river system, for instance, some of you may be familiar with that. That is the second layer, and then you have the response. If everything fails, the first and the second level fails, then you have the third level, which is the response, the emergency evacuation and so on.
So, any questions? Okay. Then thank you, Peter.